This video covers part 2 of the 2.2 section, writing linear equations. The slope of a line M represents the change in y over the change in x. So we often call that the rate of change. Later we'll call that the average rate of change. Given 2 points, x sub 1, y sub 1, and x sub 2, y sub 2, the following formula determines the slope of a line containing these points. So here's that formula. M equals y sub 2 minus y sub 1, all divided by x sub 2 minus x sub 1. So it's really just the difference in the vertical over the distance in the horizontal. Sometimes we write that as, a lot of times we write that as delta y. So a little triangle with a y. Delta x. Triangle is delta in Greek. Slope-intercept form. Y equals mx plus b. Slope is m. Y-intercept, we notate that as b. So you should have seen this before. Again, read your book for more details on this or ask me some questions about it. This point slope form, y minus y sub 1 equals m times quantity x minus x sub 1. I just want to point out that is just a different form of your slope formula. If you were to take the slope formula, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, and you were to multiply both sides by the LCD, x sub 2 minus x sub 1, x sub 2 minus x sub 1 on both sides there, then you would end up with m times x sub 2 minus x sub 1 equals y sub 2 minus y sub 1. And we take the subscripts off this, the second x and the second y, so that we just have it as a generic form and that we can use it as a formula, so to speak. And if you were then to distribute the m and simplify, you would solve out for y, which would give you the y equals mx plus b form. So we'll be doing that in these examples. Another review thing to look at here is two non-vertical lines with slopes m sub 1 and m sub 2. The subscripts are just saying like the slope of the first line, the slope of the second line. They are parallel if the lines have the same slope, and m sub 1 equals m sub 2. They are perpendicular if the slopes are negative reciprocals. So that would look like m sub 2 equals negative 1 over m sub 1. You could also figure that out equivalently by saying, or maybe calculating out m sub 1 times m sub 2 and finding it to be negative 1. For the following exercises, find the equation of the line using the point slope formula. Write all the final equations using slope-intercept form. So that's where we're going to do that simplifying. There are other ways that you can do this, which I'll talk about in some of the equations. We don't always use the slope-intercept form. We can just figure out what b is by plugging in a point and then pop it in there. But I want to show you both methods. So for number 4, we have the point 1, 2 with a slope of negative 4/5. So we want to find the equation of the line. So first I'm going to write down the point slope formula, which, as you may recall, is y minus y sub 1 equals m times x minus x sub 1. So we have a point and we have a slope, so we can just go ahead and write that right in there. We're going to leave the y, right? Minus y sub 1 is 2. I'm going to label those over here. X sub 1 is 1, y sub 1 is 2. I'm going to pop that in there, equals the slope, which is minus 4/5. And then I write the parentheses x minus x sub 1. I'm going to put in 1 for that. And then I'm going to go ahead and distribute the negative 4/5 to the x and the minus 1. So I end up with y minus 2 on the left-hand side equals negative 4/5 x. Oops. And then plus 4/5. Now we just need to add 2 to both sides. And we end up with y equals negative 4/5 x plus 2 4/5, which off to the side, I'm going to just figure out what that is as an improper fraction. So that would be 2 times 5 is 10 plus 4 is 14 over 5. So I just did that kind of separately. Now that is our equation. I am going to show you how to graph this. It doesn't say to graph it here, but I just want to review that really quickly. So I'm going to have you get out your graph paper that I posted or whatever graph paper you have to use, and I'm going to switch screens. So I have a graph grid here with an XY axis and 5 units up and down all around. So what I did was just rewrite the equation. Y equals negative 4/5 x plus 14/5. Now this one's has fractions, so sometimes people shy away from graphing these, but I just want to show you can just use a table graph. You don't need to use the intercept method. That might be tricky, or even if you've done like point slope graphing, you just plot a point, usually the y-intercept, and then use the slope to find a different point. This would be tricky with this one. So what I did was just the y-intercept I know is 0 and 14/5, so that's right about 2 4/5. I estimated where that dot would go on the y-axis, and then I just plugged in 5 for the other x value. And normally we want to try to reduce things out, but because I want to keep a common denominator, I just went ahead and wrote y equals the negative 20 over 5 plus 14/5, and I get negative 6/5. So that's about negative 1 and, well, that is negative 1 1/5, but I put whereabouts it is on the graph. So I have my x value is 5 and my y value is negative 6/5. Then the next thing I would do is I'm going to pick up this little ruler, see how this works for me. And I connect the dots here, and then I draw a line. And then I want to add arrows on the end. I want to extend my line across both axes. I also want to label things. So I want to have this lower point here, 5, negative 6/5 in parentheses. And I would have the y-intercept as 0, 14/5 in parentheses. So that's it for the graphing. Just a review on that. There are some simpler methods, and I can show you more upon request too. I'll probably do a couple more in the video as well. Maybe I'll make a separate video for that. So problem 5 is negative 3, 10 is our first point, and 5, negative 6 is our second point. It really doesn't matter which one you call first and second. Normally we kind of read left to right, so however it laid out is fine. Then I want to write an equation of a line. It's the instruction said to use point slope form again. y minus y sub 1 equals m times x minus x sub 1 in parentheses. So the problem is, though, I don't have a slope for this one, so I need to figure that out first. So first I'm going to write the slope formula over here as a reminder. M equals y sub 2 minus y sub 1. You might hear it said y2 minus y1 sometimes, just to be briefer. And then all divided by x sub 2 minus x sub 1. Then I'm just going to plug in the values and figure out slope. So I'll do that right below here. M equals, so my y sub 2 is actually negative 6, minus y sub 1 is 10, all divided by x sub 2 is 5. Make sure you get them lined up right. And minus negative 3, so I have that double negative there. I'm going to change that to plus plus right off the bat. And then my slope comes out to be negative 16 divided by 8, which equals negative 2, which is a little nicer to work with than a fraction. So then I go back to my point slope form and plug in y minus y sub 1. I'm just going to randomly pick that first one, negative 3, 10. So my 10 is the y value, equals m is negative 2, parentheses x minus x sub 1 is negative 3. Again, I have that double negative in the middle, so I'm going to make it a positive. And then I'm going to just clean it up, distribute this negative 2, so I have y minus 10 equals negative 2x minus 6, add 10 to both sides, and then I end up with y equals negative 2x plus 4. And that would be the equation of that line. One thing I want to point out too is there are other methods to figure this out. Sometimes you're given, points that work nicely, like you're already given the y-intercept and you can just pop right in there. Sometimes on this next one, you're given the x-intercept. So you can kind of judge it. If you're not sure, too, you could also plot these 2 points on a graph and look and make sure it lines up with what you came out for an equation. You don't have to do that, but you can always double check it that way on a test or something. So number 6, be careful here because it says the x-intercept is 1. So one of my points is 1, 0. So remember I was saying if you're given the y-intercept, you can just pop right into y equals mx plus b and pop the b in, but you don't have b. You have the x-intercept, not the y-intercept. And another point is negative 2, 6. So negative 2, 6 in parentheses. Again, you would go through the same process and figure out your slope and all that. You can, instead of using the point slope form, I want to try showing you just how you would find b just using slope-intercept. So the first thing that we would do, again, I'm just going to off to the side here write the slope formula. I already have the formula on the page, so I'm not going to write it again, but I'm going to write the values in there. So m equals 6 minus 0 in the numerator and negative 2 minus 1 in the denominator, and that equals 6 divided by negative 3, which equals negative 2. Now what I can do is just write down y equals mx plus b, and I can fill in what I have. Instead of using things like a subscript, I can just put in a point. And remember, I can't just directly put in for b, but I can figure out what b is going to be because I have 1 point, I have 1, 0, so I would put 0 for y, M I know is -2, so I can pop that in there. The x on that point I'm looking at, 1, 0, is 1. And then plus b. So using algebra, I can solve. I could have used either point to plug in there, but I don't want to put in both somehow. I don't know how that would be possible, but in this particular run. So I would just solve for b. So I would have 0 equals -2 times 1 is going to become just -2 plus b. Add 2 to both sides, and I get 2 equals b. So now I can put all my data back in to here in the y equals mx plus b. So my answer would come out to be y, I just want to go back to the generic, equals m, I'm going to use my slope or rate of change, and then x, generic, because I'm using this as a formula, remember, and then b is a +2, so I write +2. And that is my equation, y equals -2x plus 2. And I'm going to show you how to graph that really quick just using a point. So now we're going to graph y equals -2x plus 2 using a point slope type graphing, slope-intercept really. So we have +2 we want to plot first. That's the point 0, 2 is our y-intercept. Really could pick any point, but that's the most apparent one. And then we have a slope of -2. So that's really like m equals -2 over 1. And it's our rise or fall over our run. If it's positive, we run right. If it's negative, we run left. So we want to go down 2 units and then over 1. So I'm just tracking that so you can tell what I'm doing. Kind of makes a little slope triangle, and then I'm going to plot the point there. So the point actually got plotted at 1, 0, the x-intercept. Then I'm going to go forward again and get another point going down to right 1 plot. So that's at the point 2, -2. I could keep going in this manner. It's like a staircase. If I ran out of room, I would go back to my y-intercept instead of the new point, just so I can go in the reverse order, because -2 over 1 is actually the same as 2 over -1, right? So I could actually go up to left 1 and plot that way. And then I would want to get my ruler out and line it up on those dots. And it's a little tricky with my app here. So I'm going to go ahead and line up, extend across both axes, and add arrows. And label 2 points. That's important. I usually ask you to label a couple points. I'm going to get rid of these extra little marks. So I usually label the intercepts if it's easy enough to tell. If I didn't know the exact number of if it was a fraction on one of the intercepts, I would pick something else, or I would just do my best. I might need to figure them out algebraically for sure though. So the x-intercept is 1, 0. I'm going to label that also, and then I would be done with that. This video is getting a little bit long, so again, you always feel free to kind of go faster through them and get what you need. You can speed me up a little. I tend to go slower than maybe you need. But I'm going to stop this one here, and then we're going to take up with parallel and perpendicular lines. I feel like that might be a little bit newer for you, so I want to make sure we spend plenty of time on that. And again, feel free to kind of pick and choose. You might just want to do all the problems out and then check your answers against the video, whatever works for you. Thanks for watching.